In this lesson, you will learn about solving simple quadratic equations. Let's first take a look at what a quadratic equation is. Here it says, what is the difference between a quadratic and linear equation? If you look at this first equation, this is called a quadratic equation. The second equation, which you should be more familiar with, is called a linear equation. A quadratic equation has the highest exponent of 2, where a linear equation, its highest exponent is 1. In addition, in a quadratic equation, its graph will be the shape of what we call a parabola. A linear equation simply graphs a line. Now we will be focusing on quadratic equations. Let me give you an idea of what this would look like. To graph the quadratic equation, I'm just going to put 3 points on the graph, which you will not necessarily know how to find at this point. It's just to show you what the graph looks like. For this quadratic equation, it has what we call a vertex at -3, -1. And this is going to be the bottom of our U-shaped graph or parabola. It also has 2 x-intercepts. One of the x-intercepts is at -2, and one of them is at -4. There are also additional points. We're just going to sketch this graph. When we sketch it, it's going to look like a U-shaped graph. Now, every parabola has what's called an axis of symmetry. This axis of symmetry simply cuts the parabola in half, and each half should be a mirror image of each other. Now, in number 2, the linear equation, this simply graphs a line, which you should have done in previous lessons. So using the slope, or we can use y equals mx plus b, the slope, the number in front of x, is 1/1, which is the rise over the run. And then the y-intercept is the b, which is the 2, so 0, 2. So if we graph a point at 0, 2, which is our y-intercept, and we use our slope to go up 1 and right 1 several times, or you can reverse that pattern, you will see we have a straight line. So anytime the highest exponent is a 2, that's a quadratic, and we'll graph a parabola. Anytime the highest exponent of the x is a 1, that's a linear equation, and we'll graph a line. Now again, we're going to be focusing on quadratic equations. And what we're going to do is we're going to solve them. When we're solving them, we're trying to find the value of x that would make the equation equal to 0. And when you do that, the two solutions you're going to find, sometimes actually you would find no solution and sometimes one, those are going to be the x-intercepts of the graph. So the solutions you find are these 2 points. Now, just for example's sake, you might have a parabola that looks like this, that only has one x-intercept. And the way that you would know that when you are solving it without graphing is if you only got one answer. That means it only has one x-intercept. And then some graphs, on the other hand, they could be upside down as well. So let me draw one of those. Some graphs will never touch the x-axis, which means there are no x-intercepts. And what that means is there's no solution. It doesn't mean there's no graph, it just means there's no x-intercepts for that particular equation. So again, there's 3 scenarios for solving a quadratic equation. There could be 2 solutions, which means there's 2 x-intercepts, 1 solution, which means there's 1 x-intercept, or there could be no solution, which simply means there's no x-intercept. So let's take a look at how you solve what we call a simple quadratic. Okay, here it says, what does it mean to solve a quadratic equation? X squared minus 25 equals 0. Okay, so again, we're going to graph this as well. But to solve it, what we want to do is isolate the x squared. So similar to solving a regular linear equation, we're going to add the 25 to the right. So we will have x squared equals 25. But now what you need to do is think, what number or numbers squared equal 25? And when you're solving a quadratic equation like this, there's actually 2 answers because there are 2 numbers you could square to get 25. One of them is 5, and the other one is -5. So this one actually has two answers. The x-intercept could be 5 or it could be -5. So if I were graphing this, I would put a point at 5 on the x-axis and then at -5. And then you would have to know the vertex, which would be the lowest point of the parabola, which again, you don't know how to find that yet. But I'm going to go ahead and graph this for you. Now for this particular graph, the vertex or the bottom of it is actually at way down at 0, -25. So you couldn't even find that on the graph. So it'd be somewhere way down here, which is fine. Because again, the point of solving it is more just to find the x-intercepts. And anything that you would have to graph would probably have a more reasonable vertex. But this is what this graph would approximately look like. Okay, now let's look at one without the graph, the same problem, or similar. X squared equals 25. So this one, the x squared's already isolated. So again, you're going to think, what squared equals 25? Another way to look at it is if you take the square root of both sides, taking the square root of something that's squared, those are opposites. So these actually cancel each other out, and we're just left with the square root of 25. And I know the square root of 25 is 5, but because this is an equation, we can actually write either -5 or +5, because if you plug either of those back into the x, they both will work. So those would be our two solutions, which means our two x-intercepts. Now in this problem here, this is a quadratic equation. 3x squared equals 48. We want to isolate the x squared, so we're going to divide the 3 just like we would in a linear equation. And then 48 divided by 3 is 16. So again, either at this point you can just solve the answer in your head, or you could square root both sides. So you're trying to figure out what number squared equals 16. And again, there are two answers, because you could plug in a -4 or a +4 for the x, and both would work. So remember, these are your x-intercepts if you were to actually graph this quadratic equation, which you'll be doing in a later lesson. In this problem, in order to isolate the x squared, we would first add the 6 to the right and get our constants together, and then divide by 3. Now, if you try to think of a number squared that equals 2, you won't be able to. So if you take the square root of both sides, so this will cancel the squared out. If you can't think, if it doesn't have a whole number answer or an integer answer, then what you want to do is write positive or negative. This little plus or minus sign means positive or negative radical 2. Now you could actually put radical 2 in a calculator and approximate its value. It'll be a decimal value. But for our purposes, we're going to go ahead and leave it as a radical. Now, if that 2 could have been simplified using a factor tree, you would need to do that. Another way to write this answer is x equals positive radical 2 and then negative radical 2. And those would be your two x-intercepts if you actually change them into decimals. Okay, for this problem, we're going to solve it for x squared first. So we'll have 4x squared equals, and then 24 minus 15 is 9. We're going to divide this by 4. Now, this is a fraction that we have on the right side, which is still fine. Let's go ahead and take the square root of both sides to get rid of our squared symbol with the x. Now, 9 and 4 are both perfect squares, so if you took the square roots of them individually, that would be 3 halves. But what you need to remember, and this is the part that people forget, is when you're solving a quadratic equation and you get down to the step where you're taking the square root of the right side, you need that plus and minus sign in front. So really there's two numbers you could plug back in for this x up here, then square it, multiply it by 4, add the 15, and then get 24. There's two numbers that work. Positive 3 halves would work, and negative 3 halves. In other words, if you were to graph these x-intercepts, you'd be graphing a point at positive 1.5 and at negative 1.5 on the x-axis. Okay, if you look at the next equation, x squared minus 4 equals 50. Let's isolate the x squared. So we have x squared equals 54. So if you tried to think of a number squared that equals 54, there would be no number you could think of because it's not a perfect square. So we can go ahead and put our little positive or negative symbol. What you need to do is make sure that 54, or see if it can be broken down any further using a factor tree. So you could break it down into 2 and 27, 3 and 9, and 3 and 3. So we would have a 2, a 3, a 3, and a 3. Remember to underline your pairs and then circle anything that's not part of a pair. So whatever's not part of a pair, you'll multiply and keep under the radical. Whatever is part of a pair, you can think of it two ways. You can either take it or multiply them together, which would be 9, and then take its square root, and that's what goes on the outside. Or anything that's part of a pair, just take one of them and move it to the outside. So it'd be 3 radical 6. So our answer, fully simplified, would be plus or minus, or positive or negative, 3 radical 6, which can also be written as 3 radical 6, comma, 3 radical 6. I'm sorry, negative 3 radical 6. And those would be our two x-intercepts, which we could put in the calculator and get their decimal values, but we're not going to. Okay, in this problem, in order to isolate, we've got x squared divided by 5. So the opposite of dividing 5 would be multiplying. So to isolate the x squared, we multiply 5 on both sides. And again, 20 is not a perfect square, so there's no number squared that equals 20. So we're going to square root both sides. And then if you did a factor tree for 20, you would see that it would further simplify. So we have a pair of 2's and a 5 left over. So if you multiply the pair and take its square root, you would get 2. Or you can simply take one of that pair out, and that would be the same thing. So we get 2 radical 5. So positive or negative 2 radical 5 is our answer. Okay, in this one, to isolate the x squared, we're going to divide by 64. So we have x squared equals 25 over 64. Square root both sides. And put our little plus or minus sign in front for positive or negative. Now in this one, just like another one that we had done, because 25 and 64 are both perfect squares, we can take the square root of both, and we end up with 5/8. So our two answers are positive 5/8 and negative 5/8. Those would be the x-intercepts if you graphed this quadratic equation. Okay, moving on to this one. This one looks a little different because we have an x minus 4 in parentheses. We want to isolate this right here. So we first want to move the 81 to the other side. And then I'll show you what to do after that. Now, at this point, just like in the other one, anytime you're trying to get rid of a little squared symbol, if you take the square root of both sides, that will get rid of your squared symbol because a square root sign will cancel out the squared symbol. So what we have left is just the x minus 4. On the right, we have the square root of 81. Now again, because we're solving an equation, we're going to write positive and negative, and then when we take the square root of 81, we get 9. Now, the way that you handle it from here, if you add 4 to both sides, the way you're going to get your two answers is going to be like this. Right here, we have a positive 9 and a negative 9. And then we're going to add 4 after that. So again, the way we read this is positive or negative 9 plus 4. So we need a positive 9 plus 4 and a negative 9 plus 4. So our two x-intercepts, or solutions, will be 13 and negative 5. Okay, this one has a little bit extra because you have this 4 here, but we'll start out the same way. We want to isolate this part right here. So we're going to add the 25. So we would have 4 times x minus 3 squared equals 25. Now to finish isolating this part right here, since 4 is being multiplied by the x minus 3, to move it over, we're going to divide it. At this point, we need to get rid of our little squared symbol, so that's when you take the square root. So you'll have x minus 3, because this will cancel this out, and only the x minus 3 will be left. We're going to put our plus or minus symbol. The square root of 25/4, if you take the square root of both of those, would be 5/2. Now if I add 3 to the other side, I'm going to put it on the right of it this time. What I'm actually going to calculate is positive 5/2 plus 3, and then negative 5/2 plus 3. So if you get a common denominator so you can add them, you can keep the 5/2, but the denominator of the 3 would have to change to a 2. So we would make that 6/2 because that still divides to 3. And then if we add our numerator, we get 11/2 as one of our answers. So then we'll use negative 5/2 plus 6/2. And then if we add the numerators, we would get a positive 1/2 for our second answer. So those would be the two x-intercepts, or the two solutions of our quadratic equation. And that completes the first part of solving quadratic equations. These are called simple quadratic equations because they can solve without the process of factoring, which will be learned in a future lesson. Good luck.